he shoots and scores. Oh, hi. Hey, it's March, and I'm getting excited for March Madness. But first, let's tape a lesson on lesson 9-1. We're starting a new chapter on quadratic equations. For some reason, that is considered a quadratic equation. And it always, I don't know, it puzzles me a little bit because quad, it makes me think of 4, and then it's something squared as a quadratic equation, but it is what it is, okay? So usually they write, this is called standard form. All quadratic equations can be written like this. Y equals ax squared plus bx plus c. Now the one I just wrote there, y equals x squared, that would be a quadratic equation. What would the a be? It would be the coefficient in front of here. There's an assumed 1. And then b would be 0, and it makes that go away. And c would also be 0, so there's nothing really there. Kind of a more common one. Let me just pick one out of your book. Example 1 gives you y equals 3x squared plus 6x minus 4. Okay, so see how it fits with the standard form? In this case, a would be 3, b would be 6, and c would be negative 4. Do you all see that? If I'm not standing in the way? Okay, so hopefully that makes sense to you. So standard form, A, B, C. Now, when you end up graphing something like this, well, actually, let me just say, in our last chapter, we did things like this. Didn't have that, and you learned how to factor something like this. In this chapter, we're going to go on and we're going to graph things like this. Next year, I have to say, when you have a graphing calculator in high school, it'll be a lot easier. You just plug that in, say graph, it'll graph it for you. We're not going to do that this year because I want you all to be on the same playing field. Also, just graphing calculators are more computing power than what I really want you to have in class right now. I don't want you to store formulas and things like that in those. So let's save that for high school. And here we're just going to use, what we're going to do is we're going to use a t-chart. Okay? So we'll put in some x and y's, and we're going to make a graph. When you graph something like this, let me just tell you, I'll spoil some of the surprise. It's going to turn out to look something like this. That shape is called a parabola. And there's some factors, or there's some characteristics I want you to see. It goes on forever in this direction. So it has no end, but it does, this one has a lowest point, okay? They call that the minimum of the parabola. Sometimes parabolas will go the other way, and they'll have not a minimum, but they'll have a maximum. The highest or lowest point, that's called the vertex of the parabola. Sometimes the parabola might be shifted over like this. Sometimes and actually you could have one, this would be a little odd, open up sideways. Okay, that would be if it was like x equals y squared, but let's not worry about that right now. The other thing I want you to notice about parabolas is that they're what's called symmetric. You know how like a person, we could fold our arms over on each other, we could fold our legs over, we have 2 eyes. We're bilaterally symmetrical, and so are parabolas. This one here that I drew has an axis of symmetry that goes right along the y-axis, and if we folded that over, it would match up. It's not always going to be the y-axis. The little formula, the quick way to find the axis of symmetry is, this is written also in your book on page 543. In the very first part where they say key concept, quadratic functions, they say the equation for the axis of symmetry is x equals the opposite of b over 2a. So I have my a, b, and c that I've already picked out from my formula. So the opposite of b is going to be negative 6 over 2a. 2 times 3 is going to be 6. So the axis of symmetry is going to be x equals negative 1. And if you remember from our graphing, you know that means it's going to be a line going straight up and down, and it crosses at negative 1. There's the axis of symmetry. The way that that's going to help us is it's going to cut down on a lot of the guessing as far as the x and y. So let me first of all draw that in the graph. And I'm just going to do kind of a dotted line so you can see it. So at x equals negative 1, we're going to have a dotted line going up and down. So we know now that our parabola is centered around that axis. So I'm going to put in negative 1 as one of my x's, and I'll see what y we get. When I put negative 1 in there, negative 1 times negative 1 is 1. 1 times 3 is 3. When I put negative 1 in there, it makes it negative 6. So 3 minus 6. And then I have minus 4. So 3 minus 6 is negative 3. Minus 4 is negative 7. So in other words, at that point, when I go over negative 1, I'm going to go down 7. 1, 2, 3, 4, 5, 6, 7. And that's where my dot is going to be. That's where I know the vertex is going to be. I don't know whether it's a minimum or maximum right now, but I can put a dot there. Then I'm going to go on each side of that. So I'm going to go at 0, and I'm going to go at negative 2. And I'll plug those in. Put 0 in here, and do you see I'm going to get negative 4? And when I put negative 2 in there and I work it out, it's also going to be negative 4. So from negative 7, so when I go to 0, I'm going to go down 4. 1, 2, 3, 4. And also on the other side there, I'll go there. So do you see we have our first part of this parabola. We have a shape happening here. It's going to look something like that. It's not going to be straight lines. And in fact, if you picked like a point negative 1/2 and and negative 3/2, you could even get closer. But for right now, you can just kind of smooth it out as you draw it. That's okay. Let's pick one more. So we'll pick positive 1 and negative 1, 2. We'll pick negative 3. Oops, negative 3. So when I put in positive 1, get rid of this. I'm going to get 1 times 1 is 1 times 3, 3. 1 times 6 is 6. Minus 4, so I'm going to get 9 minus 4, so I'm going to get 5. And when I put that in there, I'm also going to get 5. So I go over 1 and up 5. 1, 2, 3, 4, about right here. And when I do the same thing on the other side, I'll go up about the same amount. And so do you see it? Now I can draw the rest of, or at least the next part of my parabola. And then I'm just going to put arrows on it, because that's enough. You don't need to draw more than that. So do you understand the process? I think it's easiest if you find the axis of symmetry, use this formula. First of all, make sure it's in standard form. Use that formula, figure out the axis of symmetry, and then you're just going to plug those into a T-chart on the axis of symmetry, and then on each side of it, and then on each side of that, and then you'll find points, and then you just graph them. There's something else that they might ask you to look for, and that's called the zeros of the parabola. Wherever that crosses, what they mean by zeros is they mean the places where y equals 0. So that means where it crosses the x-axis. So one of the zeros looks like it's going to be there, and I don't know if I drew this correctly, but one of the zeros looks like it's going to be about right there. Okay? They might ask you to estimate those. Is there anything else? Oh, they might ask you the domain and range. Let's kind of clean this up a little bit. So if they gave you a graph like this and they asked you the domain and range, remember the domain is the x values. So along the x-axis, this goes up forever, but it also is spreading out forever. It never comes back in. So since it's spreading out forever, eventually, if I went up high enough, it's going to reach every x value. So the domain is going to be all real numbers. The range, if we think about it, it's going to reach every positive number, but it's not going to reach every negative one. And in fact, we know that it started at negative 11. So it's going to be the y values greater than or equal to negative 11. Okay? Does that make sense? Okay, I think that's the main part from this section. Let me just check it. It's going to be a little tedious graphing this way. I'm not going to give you a ton of problems each night, but I think that this will get you started. Okay? All right, out.